Welcome to our channel, where we explore metal additive manufacturing technologies. Today, we'll answer a question we often get asked from people at the start of their additive manufacturing journey. We'll be focusing on two major processes: selective laser melting, or SLM, and traditional casting. As we compare these technologies, we'll examine their efficiencies, material usage, part quality, cost-effectiveness, and their specific roles within different sectors. Let's start by understanding what sets these technologies apart. SLM is at the forefront of additive manufacturing, utilizing high-powered lasers to melt fine metal powders layer by layer, directly from CAD models. This allows for the creation of parts with complex geometries and intricate details that traditional methods might not achieve. It's particularly favored in sectors like aerospace, automotive, and healthcare, using materials such as titanium, stainless steel, and nickel alloys. On the other side, we have traditional casting, a more conventional method where molten metal is poured into a pre-shaped mold. As the metal cools and solidifies, it forms the parts. This method is incredibly versatile and suitable for a variety of metals and casting processes like sand, die, and investment casting. While perfect for large-scale production, traditional casting does face limitations, especially when it comes to the complexity of the molds. Now let's compare these processes in more detail. When it comes to complexity and design flexibility, SLM stands out by enabling the production of intricate designs and complex internal structures without additional costs. Traditional casting, however, is often constrained by the mold's capabilities, which can make it challenging to achieve undercuts and internal features without resorting to multiple molds or complex setups. In terms of material utilization and waste, SLM is exceptionally efficient, using only the necessary amount of metal powder for each layer, thus significantly reducing waste. In contrast, casting can lead to substantial material wastage due to gating systems, excess material, and sometimes the mold itself if it's not reusable. Looking at the quality and performance of manufactured parts, SLM parts typically showcase excellent mechanical properties due to the fine control over microstructure provided by the technology. Traditional casting, however, might encounter issues such as porosity and inclusion, which can compromise the mechanical integrity of the parts. If we consider surface finish and post-processing requirements, SLM parts often require significant post-processing to achieve a smooth finish. Cast parts generally have better surface quality right out of the mold, dependent on the mold's finish, but they may still need further finishing processes. Discussing production time and cost effectiveness, SLM is generally faster at producing small batches of complex parts, although it can be pricey due to initial setup and material costs. Casting, on the other hand, becomes more cost-effective at larger volumes, despite the initial expenses involved in mold making. As for applications and industry adoption, SLM is increasingly favored in industries that require customization and complex geometries, such as aerospace and healthcare. Casting continues to be predominant in industries needing large, less complex components, like automotive and heavy machinery. Looking forward, we anticipate advancements in SLM that will enhance its speed and material capabilities. Meanwhile, innovations in casting technologies are focusing on improving precision and reducing environmental impacts. In conclusion, both selective laser melting and traditional casting offer unique advantages and are suitable for specific applications. The choice between them should be guided by project-specific requirements, taking into account factors like production volume, part complexity, and overall cost. Thank you for joining us today. Don't forget to subscribe and check out our website.